Hello everyone. Today we are going to talk about pulse width modulation. Then we are going to put a circuit together and demonstrate it using Arduino. For many electronic components, the performance depends on the amount of power. For example, for a motor, higher the power, higher the speed and torque. Similarly, for LED, the higher the power and brighter the LED. Pulse width modulation is a novel way to control the total power output when the signal is digital type. Pulse width modulation is a way to represent data over a communications channel. With pulse width modulation, the value of a sample of data is represented by the length of a pulse. Let's understand the idea of the duty cycle relative to the period of the signal. It's usually given as a percentage. For example, a perfect square wave with equal high time and low time has a duty cycle of 50%. Similarly, 25% duty cycle means power is available over 25% of the duration, whereas there is no power available over the 75% of the cycle. Therefore, total power available is 25% of the maximum digital output. Let's understand this idea with the water filling analogy. Total water reaching to the receiver container can be controlled in two ways. First, you can control the rate at which the water is being poured. Alternatively, when the rate of pouring is fixed, you can control the total water by controlling the frequency of the pouring. Let's build a circuit and understand this concept more with the help of Arduino microcontroller. Here is a simple circuit for generating a pulse width modulation at the digital pin number 6. Here is the list of components that are required to build this circuit. One USB cable to connect the computer to the microcontroller. One breadboard. One LED. One 220 ohm resistor. Some jumper wires. Let us connect the resistor on the breadboard. For the LED, you might be aware that the longer leg of the LED is positive and the shorter is negative. We are going to connect the positive side of the LED to a digital pin 6 via the resistor and negative pin to ground. This is how overall circuits look. Now we are going to write a code. Here we have defined the LED variable LED pin as the output by using the pin mode function. The code has two for loops. The first loop is responsible for generating a pulse from modulation of different duty cycles, varying from 0 to 255. 255 corresponds to 100% duty cycles. The first for loop uses variable I and starts increasing the analog signal, PWM, values from 0 to 255. This makes the LED fade and glow by writing its immediate value on the LED pin variable. The second for loop uses the same variable, I, but decreases the analog value starting from 255 and ending on 0. This makes the LED fade out and dim by writing its immediate value on the LED pin variable. Let's download the code to Arduino. As expected, the circuit displays the brightness of the LED going from 0 to maximum in the first instance. In the second, the brightness fades from maximum to 0. Instead of using the for loop, you can also provide a fixed value as the output is shown in this code. As an experiment, you can change the value of pulse width and observe the change in LED brightness. Change the PWM value to 0, 25, 125, 175, 200, 225, 255, and verify the intensity of the LED. You can also vary the brightness in Sawtooth mode. That is, the brightness increases gradually and then drops to 0. We shall have the motor speed and direction control using pulse width modulation coming soon. I hope you find this tutorial useful. Please like and subscribe. Thanks for watching!